Cool.
So to George.
All good? Yeah, thank you very much, everybody. Thank you very much, Patrick, as well for the talk. It was very interesting. And in the same vein of server-based UI, I'm going to be jumping in and showing how to build an interface between Flutter and Unreal using WebRTC and then a little bit of cloud at the end. Cool. So by the end of the session, you'll be able to understand how to interface with Unreal and your Flutter application. You'll also be able to structure this further beyond Unreal and use Flutter and WebRTC for any kind of like peripheral device that uses WebRTC, obviously. Understand how I, in particular, and maybe you would go about architecting your project as well. And then again, extending that architecture for your own peer-to-peer real-time applications. Cool. So for those of you who do not know, Unreal is obviously a game engine. It's built a huge amount of things, but it's also scaled into a huge amount of different use cases as well. Obviously, you have games as well, these blockbusters here, as you can see, like Assassin's Creed as well. It's also made films as well, so they've used Unreal to make Mandalorian or series. Cool. Also does physics simulations, like fluid simulations as well. And finally, in my use case as well, immersive 3D online worlds. All of these are made by the company I'm currently with, Imperia, and these are all web-based but built in Unreal using Flutter as like the means to make it. Cool. So just like one final overview with Unreal as well. So this is everything you can do out of the box as per their website. Like I said, games, mobile games as well, animation, automotive, architecture, you know, making 3D designs as well. And one of the best features that come out of Unreal that I believe is pretty cool is pixel streaming. So pixel streaming is essentially where you stream, obviously, your video and audio feed from a host computer or machine, whether it's physical or virtual machine. And then from there, you basically have your video feed and audio feed and associated data channels just come into Flutter or your end device, front end device, whether it's browser, mobile, anything with a screen, basically, that doesn't have the necessary processing power for what you want to do. Cool. So this is the out-of-the-box solution. So as you can see, on the top right-hand side, you have Unreal. At the bottom, you have our server running, which is coordinating between the two. And on the left-hand side, you have the browser. All of this is implemented in JavaScript and TypeScript. As you can see, I'm passing the interactions through. I can play that again whilst I explain. Passing the interactions through. So obviously move, jump, etc., etc. And it's taking those interactions from the front end and then streaming it directly down into Unreal, as you can see. So it's pretty cool. So now that we have a little bit of context as to what Unreal is, we have been assigned a mission. We have to save Fred. This is our friend, Fred. Sorry on the name. I wrote the script before I got the visuals. We are going to help Fred. Fred is the hero of our story. As you can see, very beautiful. And we need to get Fred home. Okay, Fred's stuck. He's actually stuck on the other side of the map, and we need to get him home. Luckily for us, not that big. So we can get Fred home. But we could use the out-of-the-box solution. Problem solved, right? We could just use the browser, get him home, happy days. Problem solved. Good. Cool. Done. Good night, everyone. Go home now. No, unfortunately not. It's not that easy. Fred hates web browsers, and Fred hates JavaScript and TypeScript a lot. But Fred, he loves Flutter, funnily enough. Oh, yeah! Woo for Flutter! Perfect. So what we're going to do is build something like this is our end result. Perfect. We can move Fred around and get him home. So you've had a little bit of context. We're just going to jump one more time into the system architecture, how it all works together. On the left-hand side, you have Unreal, and this has bundled together our pixel streaming infrastructure. So Unreal essentially has all the 3D environment. The pixel streaming is the coordination between that and its server, and then it communicates via WebRTC to our front end, as you can see, either the JavaScript out-of-the-box solution or our Flutter custom front end. So just more details, really. Unreal acts as our media server, self-explanatory, really. Cirrus is basically under the hood pixel streaming infrastructure as well. And like it says there, brokers the initial connection setup. We have our front end, initially TypeScript, and is our remote peer. This is what we're streaming to. And then we have WebRTC. This is our direct peer-to-peer connection, and it's very common to use in stuff like video calls and anything that kind of uses direct peer-to-peer connection, like I said. Cool. So Unreal renders, Cirrus signals, WebRTC streams, and the front end interacts. Pretty simple. Cool. So seeing as our original implementation is in JavaScript, and us, our noble Flutter developers, we're going to have to conquer this. Basically, go into their code. It's all open source. Rip it, and then stick it in Flutter. Simple. And save for it. So how do we initially connect to our pixel stream? This is how would we essentially get the initial connection set up? Anyone know? Guesses? Yes, exactly. WebSockets. So this is just an example from the terminal of setting up the server. As you can see, it's set up on the local host. And this is essentially what you see when you start running the pixel streaming. For us, like I said, we're using localhost, and then we have our WebSocket listening for connections on those various ports. Cool. So once we get that, we need to fetch the IP address from our front end. Cool. So this is the existing implementation. As you can see on the bottom right-hand side, it's essentially getting it from the config file. This won't work for us because we're not actually packaged in with the pixel stream, obviously. So I've implemented the fetch IP address here. As you can see, I've hard-coded it, but we could extend it to actually dynamically get it should we extend the project in the future. The main thing we should really be concerned with here is just line 6, which is obviously just getting the IP address. Cool. Once we've gotten the IP address, we want to obviously connect to it. And then here is a whole load of gobbledygook, but basically you want the first one, which is on open, and then this handles it. Again, this is the original implementation, and this is our implementation, and you just want to be concerned with essentially line 4. As you can see, as we connect, it returns a data channel that we can communicate down. Cool. Finally, once we've connected, we actually want to listen to the WebSocket and handle any messages that are sent to it as well. So again, this is our JavaScript implementation from the pixel streaming infrastructure. We define the types essentially we want to get through the WebSocket, and then listen to them, as you can see here. So obviously, appropriately named function. We essentially listen to the WebSocket and then handle the message accordingly, either with an internal message, which is essentially defining how the WebSocket interacts, or on business message, which is messages that we're listening to from the pixel stream WebSocket, but we want it to interact with our UI and so on. Cool. So following all of that, we are connected. We are connected to the WebSocket, but we still haven't established our audio and video. Okay. So we've connected our WebSocket, but like I said, we want to get what's going on in Unreal onto our Flutter app. So any answers here? What do we use to connect our audio and video to our front end? Yes, well done. Perfect. So WebRTC, like I said earlier, is for video calls, conference calls, common use cases like Zoom as well, Discord, any kind of like web-based video calling software. IoT as well, it's pretty cool. So with Ring, this is direct peer-to-peer. Essentially, you get the video feed, obviously, and the audio feed through your doorbell to your phone. And then peer-to-peer file sharing, which I thought was pretty cool. So BitTorrent, WebTorrent, no server intermediary, directly peer-to-peer. Cool. All right, so when it comes down to WebRTC, there's obviously 2 clients. We've got the offerer. This is someone who starts the negotiation handshake on how to essentially on starting the transmission of video and audio data. Okay, so they basically set up what data they want to send, how they're going to send it, and various other kind of settings as well. So as you can see here, this is actually an example of what is sent. This is written in SDP, which is called Session Description Protocol, and it's basically a huge text string that defines how they'd like to communicate. And this is sent across our WebSocket. And then the answerer, once they've received the offer, they then respond obviously with a appropriately named answer, which basically just then allows them to negotiate and actually establish that connection. And again, same again is the answer example. Cool. So yeah, like I said, written in SDP, so Session Description Protocol. This is just like a standard format of the strings that are sent through as offers and answers. And it defines what codecs to use, what protocols to use, transport data, and then where they're going to actually stream using the IPs and ports. Cool. All right, so before we can help Fred, I just want to take this analogy. So imagine Fred wants us to send us a letter. He wants to send us data from him to us. We have three things that happen just after we make our initial connection. We have our ICE candidates, which are essentially our postal scouts. They're the ones that traverse the network to find the best route between me and him to send data. And then we have two levels of encryption, one at each peer, and then one essentially at, within the data packet should it be intercepted. So it's pretty obvious. How do we get the offer from Unreal project and send our answer? Yes, well done. So first of all, we want to see who's streaming. This is us now on our front end looking essentially down the WebSocket data channel to see who's available. Again, this is the initial implementation where you're essentially sending a message down the data channel saying, hey, who's streaming? And again, here, this is us. This is our implementation now in Flutter. As you can see, I'm just sending a message. I'm encoding it into a string. And obviously, we're just saying, hey, list streamers, and send it down the data channel. Cool. And then here, if you'd like to look at the final line, actually, update streaming list. So essentially, when we get the streaming list through, we then update our available streamers so we know who's available to connect to. Once we have our streamers, so once we have Fred, we want to subscribe to him. We want to say, hey, we know you're there. We want to actually get your video feed now, please. So again, this is the original implementation. We send the streamer ID down and say, hey, we want to connect. And essentially, we're doing the same here from lines 6 to 9. So we're subscribing and then saying which streamer we want to subscribe to, and then sending it down our WebSocket channel. Cool. Okay, so now we are all clued up when it comes to our WebSockets, and we can actually architect our solution. So there are 3 packages that we are using essentially to make our app and help Fred get home. First is WebSocket channel. This obviously handles everything WebSocket related out of the box. Simple enough. We have Flutter WebRTC. Again, everything out of the box for you to handle any kind of WebRTC data transmission or receiving any data from WebRTC. And finally, the best state management in all of Flutter, and any other opinion is wrong, Flutter block. So this is the state management that we're going to be using today for our solution. Cool. And then using all of that, we can finally see Fred. After the WebSockets, after the WebRTC connection, we can actually get connected. So now we're going to actually move on to a little bit more with the implementation, specifically the WebSocket service. Just another high-level overview, really, of what we're going to do. So like we saw earlier, we'll fetch the IP address, connect to the WebSocket, listen to the messages from the WebSocket, request our streamers, send our answer, send our ICE candidates, and then disconnect. Cool. I can skim through these quickly as we've already seen them. So we got fetch IP address. We can connect to our WebSocket. We can listen to our messages from our WebSocket. We can request our streamers, send our answer upon receiving an offer, send our ICE candidates so we can establish the best route across the network so we can reliably send video data, and then finally disconnect. Cool. All right, another service that we're going to have is our WebRTC service. Here we're going to obviously initialize everything, set our screen dimensions, which is very important for various sizes of screens. Because essentially when you're sending in touch data, which we'll get through later, you'll obviously want to know like the normalized position of your finger. Initialize renderers, this basically sets things up so you can see stuff on screen. And then we have obviously answer our offer, initialize our peer connection, etc., etc. So we can run through those very quickly. Initialize, set our screen dimensions. Cool, initialize our renderers, like I said. Initialize our peer connection. This is essentially defines how we're going to communicate. As you can see, cool, answer offer. So essentially when we get an offer through, we set our remote description and then actually use our WebRTC package to create the answer and send it through. Cool. This essentially assigns our connection to a stream, so we can actually stream the video data through. And then very important is setting up the data channel. So unlike WebSockets where it's one connection is one data channel, for this one is actually the video and audio feed, and then you have a data channel where you can send binary data messages down in order to provide interactions. Cool, and then just finally some helper functions as well. So we can monitor our connection quality and then set up our connection state monitoring as well. Cool. So we've done our WebSocket service and our WebRTC service, the two big chunks of our project. The final one obviously is our state management. Here we have our block handlers, which is essentially my events that I've just split down, because as the project kind of grows, it can turn really quite big. So I like to fragment my events by use case essentially. Then we have our block main implementation and our state. And this is what we need our block to coordinate, basically all kind of UI interactions. So we can effectively connect to Thread through our app. Cool. And then again, just skimming through these are our block implementations. So this is us dispatching our event to fetch the WebSocket IP. Again, calling our WebRTC demo WebSocket service, sorry. Cool. And then again, connect WebSocket event, dispatching that event handler. Cool. And then again, calling our WebSocket service. And again, listening through. And here we are. This is kind of like a big beefy one. Essentially, we're listening to the status of the WebSocket, and if it changes, we're going to reflect that in the UI accordingly. Again, request our streamers. Same again. Subscribe to the streamer. Cool. Listen to WebSocket messages. Cool. And like we say, handle it accordingly. And again, just there, a bit extended. And then that's just an overview of our block as well. Cool. So you can see our WebSocket events here. All of those are there. And then our WebRTC events as well. So this is where we actually establish the connection. We run through and basically emit the relevant state based on like our connection status. And then we set up various service listeners to, again, reflect the state that we're in on the UI. Cool. And then again, set up our WebRTC data channel. Cool. Okay. And then those are our events. And then finally, when it's all come together, we actually then show our video in our widget tree using our video renderer. Cool. And now we can finally see Fred, finally, after all of that. Nice. So we can see Fred, but we can't interact with him at the moment. We got our video and audio feed, but how are we going to move him? So how do you think we will send messages to him? No. The data channel in WebRTC. Yeah. So cool. This is our setting up our WebRTC data channel. Nice. So we're just going to jump back into the original implementation to see what messages we can actually see. I'm going to skim through this very quick because I don't actually know how good you can see it. But as you can see here, these are actually all the messages that are in the original infrastructure, all the things you can kind of lift out and then send down the data channel, and then the original infrastructure will then handle it accordingly. And there's a whole bunch of them really. If you want to deep dive into it, you can get the FPS request and that kind of stuff and check the actual performance of the server. But what we're looking for really is we just want to move Fred and we want to move the camera. Cool. Like I said, move Fred, move the camera. So for this, essentially, this is obviously the original implementation again. We want a key down to indicate that we're pushing down a key. We want key up to indicate that we're lifting up a key. We want to touch start. So when we're touching the screen, indicate that we're starting touching the screen, funnily enough. Touch end, when you lift your finger off. Touch move, so obviously when you're moving, strafing your finger across the screen. And then depending on your implementation and how your pixel stream is handling it all, you will want mouse move as well, depending on how you've defined your Unreal and what machine basically it's running on. So we got mouse move as well, mouse down and mouse up. So those are essentially the same as moving the mouse, clicking the mouse, releasing the mouse. Cool. And then this is our implementation now. So as you can see here, so this is sending the button press, and we essentially convert it down to byte data. Originally, I started sending it down as strings, and I was like, why is that not working? Because sending stuff down WebRTC data channels, you need to send it down in binary. So as you can see here, we're mapping our function, mapping our interaction using our convert string to byte data to just send that down as binary down our data channel, as you can see on line 9. Cool, and then same again here, send button release. So we've got send button press, send button release. And this is us basically mapping our buttons within our UI to make sure we're sending the right key code in ASCII. I got that wrong a lot. Cool. And then this is just an example of one of the buttons in the UI. As you can see here, we're sending the key code down and then sending it through our data channel. Cool. And once we have that, we can put it all together and then create a gamepad widget, which will look like this. So as you can see here, I'm pressing the button. It's sending the correct ASCII code down the data channel and moving Fred. And the latency isn't too bad. It was on localhost, so. But the arrows are a little bit boring, to be honest. So we're going to change it to a joystick. And as you can see here, we've actually extended the functionality. So instead of moving in 4 planes of motion, we've actually got 8 degrees of movement now, which means essentially we've got to send and release pairs of keys. Because if I just play that again, essentially it's not going to be forward, back, left, and right. It's going to be, you get what I'm saying? It's you're going to send exactly, yeah. Thank you. Cool. So this is actually us handling the joystick. So I'm actually using a for loop and then sending down what's active and what's released. Cool. And now we can move Fred, and we want to move the camera as well. So this is us handling our touch gesture. We take in our local X and Y coordinates of us pressing the phone, and then normalize it, put it in normalized integer space, and essentially send it through. As you can see on line 17 and 18, we're adding those in. Cool. And then same again for touch move, touch end, and sending those through. Cool. And then exactly the same for the mouse gesture as well. Once we have all of those, we can put those in a gesture detector, which wraps our video view, and then we can send through our movements. Cool. And as you can see, now we can move the camera. Pretty cool. And this is just a comparison for latency. So what I found was actually the button presses were pretty much exact in terms of timing. But when it came to the camera, you can see it's actually a little bit of time off. And this can kind of be improved by adaptive bit rates and setting the correct resolution to Unreal, because right now it's sending through resolution of the screen on the right. And there's various other factors you can do to kind of improve that. Cool. All right, so we've connected to our WebSocket, connected to WebRTC. We can view Fred and his world. We can move Fred and move him around. Now we need to get him home. Cool. Let's get him home. But he stopped. Why is he stopped? Because Fred loves Flutter so much that we're going to dive in to our architecture a little bit more and just show you the project setup. So as you can see here, I have got app, core, and feature. All of them are in one package. If this project were to grow, I would extrapolate those out and basically have one package per feature, just so then like any dependencies that become outdated won't affect the entire app. But right now we have app, core, and feature, like I said. In our app, we have our app barrel file. This just exports out everything that we need, so we don't spam our project with import messages from everything we're using within the app. In here, we're using getit as well for dependency injection, set up in our service locator.dart file. So as you can see here in our service locator, essentially we are just registering all of our services and then passing them through. Cool. And then in our main, we're just going to call that so our services are available app-wide. Moving on, we have our core folder. This has our design system, our services, and our utils. With our design system, essentially this contains everything when it comes to fonts, widgets, theming, colors, etc. And mine's empty because I don't have a designer. But if you did have one, that's where they would live. Second, we have services. Like I said, what we previously defined, we have our WebRTC service and our WebSocket service, so it's available throughout the app. In our WebRTC service, we have our, at the bottom, we have our WebRTC service, and then our message controller, which handles all the formatting of all the messages as well. So in our WebSocket service, same again. So we have a WebSocket service and then a WebSocket message handler. Cool. And then our final in utils, we have our logger, which essentially just allows us to have a little bit more of a granular control over the debug prints I had, which I needed a lot of. So you can just set the level accordingly throughout your code. Cool. And then finally our barrel file as well. Perfect. All right. Final one, feature. Here we have, this is pretty much everything to do with the UI. So we have our block, pages, and widgets within our views folder, and then we have our feature barrel file as well. So in our block, like I said earlier, we have our block handlers, we have our state, our main block implementation, and there. And then these are, like I saw earlier, our WebSocket events, just a refresher, our WebRTC events, all of our states as well, and then our final block implementation. Cool. We got here, cool. And then in our block handlers as well. So this is where I've actually broken down the events. So if we go back here, I don't actually have any implementations of the event handler in the event. I actually fragment them out because when your project grows, it's going to get absolutely massive and really disgusting. So this is where I've fragmented it out into our connection handlers, our WebRTC handlers, and our WebSocket handlers accordingly. And then again, you can see here, this is just an example of our WebRTC handler and extension of our block as well. Cool. And then same again, extension of our block as well for the WebSockets, and then our WebRTC connection as well. Cool. All right. Now that we have all of that, we can finally jump into our stream view, which essentially has our gesture detector, like I said, so we can detect our movements with our finger and move the camera. And then we have our RTC video view, which is a widget out of the WebRTC package. And then this takes in our video renderer, which allows us to view the video feed as well. And finally, our gamepad. Cool. And then finally, obviously, our feature barrel file. Cool. Fred's happy. So we can continue getting Fred home. This was really hard. Yeah. Cool. But he stopped again. Unfortunately, he's moody today because he's frightened of our WebSocket implementation. Very fragile. We have a simple connect, but we don't have any kind of reconnection logic. So this is our original implementation, connect to WebSocket. as you can see here, we literally just have that, and then we throw an exception if we don't connect. Not so good. So what we can do is actually extend our WebSocket service. Sorry for the massive amount there, but essentially what we're doing is implementing exponential backoff, which means we try and connect, and then every step, if we don't get a connection, we wait a bit, try and connect again, wait a bit longer, try and connect again. And as you can see, so essentially we've got our jitter factor here, which helps us kind of avoid stampeding herds or something like that, and essentially means that if everyone tries to reconnect at the same time, it doesn't overload the infrastructure. Cool. Fred's happy. We can finally try and get Fred home again. Almost there, I promise you. But there's one more thing. And then we're done, I promise. Cool. So Fred just wants to double check and basically tell us he doesn't like us using our local host. He doesn't like us using our simulator. He wants us to have more control and basically be more reliable and connect to him wherever we are in the world so we can help him get home. So what you can actually do here is, as you saw with the previous implementation, we had Unreal running on a local machine. What you can actually do is package Unreal and the pixel streaming into a VM. And as we're Flutter developers, we love the Google stack. So I recommend basically packaging up our Unreal and our pixel streaming into a VM, and then you can basically serve your IP address of wherever that virtual machine is running. Cool. And finally, we can get Fred home. Yes, Fred. Cool.
Although I wanted to know what was that about.
Oh, I probably.
All right, second question. What if the connection drops, the WebSocket connection drops? Does it like just skip some frames in the?
So if the WebSocket drops, I can try and find the code. Essentially, what it does is out the block handler, and then connected. So this is just a very quick. These are all the steps that we followed today. As you can see, this is the initial. So we're not connected to the website. But when I get to the end, okay. So
any more questions? Yes. Have you, a great presentation, by the way, really good. Have you had to deal with blocked connections, like implementing a stun or turn server to relay connections and TCP, stuff, that sort of stuff?
So, expose these kind of network issues. So for those of you who don't know, stun is basically a server that allows you to establish the best connection, and if that's not available, it relays back to turn. And I'd always ever really used stun because I was obviously in a home environment, and actually going around now in various coffee shops and hotels and that kind of stuff, it was a lot relying on turn. For me, it just handled it the same because there is infrastructure on the pixel streaming side that just handles that for you. And that's basically goes through the moment.
Cool. Any more? Yes.
Oh, that was an amazing one. I really liked it. And it feels like having, what was it, the personal Stadia kind of setup. I wonder, what kind of data can you transmit? Are you limited only to the data types defined in WebRTC, or can you transmit your own type of data instead of touch start, touch end?
Yeah,
both?
so those methods that we saw were strictly defined by the server, and that's what the server is expecting. But when it comes to WebRTC, it's you can literally do anything that you can turn down to binary, because binary is what's sent through the data channel. So you can do out the box like video and audio, but then also send anything like I said that you can put down into binary and then just be consumed by a recipient.
That's awesome. Thank you very much.
No problem.
Any more questions? No? Okay. All right. Well, thank you very much, James. Really very nice presentation.